the special case of the sine law. So I'm going to talk about one particular case. I am going to do a full-out summary of all the sines and cosine laws and how you can do that. Once that video goes up, I'll put up a link up above there. Okay. Now for this video, I'm going to take one special case where it may seem that you can use the sine law, which you can, but you have to be careful on how those triangles are actually constructed so you don't fall in a trap and calculate the wrong thing. So this special case, sometimes called the ambiguous case, happens when you have basically an angle and then two consecutive sides given. And so for instance, so you have this angle A, and I'm going to refer to those capitalized letters as the angles, okay, that we have, and then the small letters are going to be just the lengths of the sides, and notice that they're opposite each other. So let's say you have this angle given, and then you have two consecutive sides, so angle C and angle A given. So that's a very, very special case. And if you may remember, in terms of congruent triangles, you can put up a link up above there for congruent triangles. But if this was given, then we would have kind of designated this as, an angle given and then a side and a side. And notice the acronym. So most teachers won't actually typically write this because, what it spells out isn't a very nice word, but I guess that depends. Okay, so it's an angle and then a side that's given. That's the ambiguous special case. Now, don't forget, you can also read it from the back, right? So this is sometimes what what teachers might do, okay, so that it doesn't spell out. I like using this one because that's how actually I remember it. A.S.S, you can say it if you like, okay? That's what makes me remember this special case. S.S.A is not very memorable. A.S.S is pretty memorable. Okay. Now both of these are identical because you can read them as here's your side, and your angle that's given right there, or you can go in reverse. So I like to use this one instead. Okay. Now in this case, if you would notice this, and it doesn't have to be angle A and then the side C and then angle and the side A. Right? It can be any combinations of those as long as you have an angle that's given and then two consecutive sides. Okay? Because we can just rewrite the A's, the B's, and the C's, okay, to whatever it is that we like, or we can rotate the triangle, okay, as needed. Now, if you have this given, and here is your sine law right here, kind of that you have studied, and maybe I'll put up a link up above there again, if you want to see where that came from, then you will notice that you can actually use this to your advantage because now okay, so that means if I know the angle, okay, right here, I know the side right here, and then I know this right there, so I can say, oh, okay, well now I can find the angle C, and that would have been, so sine of A over A is equal to sine of C over C. You can rewrite that, and since you know these three, you can say, since you know these three, you can say, all right, well, I can find this angle, no problem. And it's true, you can find it, okay? But I'll show you why it's ambiguous and why it's a little bit tricky in just a moment, all right? Now, once you have that angle C, then obviously you can find the angle B, and then you can find the length B as well, because if you have two of the angles in a triangle, then the third angle can be just found by the identity of 180 degrees minus the two angles. Okay, so now where does the problem lie here? And this will all depend on how the triangles are constructed. So this is what you're going to have to be careful in the problems and then using whenever you have A.S.S kind of given to you. Okay, so let me delete this out. Okay, and now hopefully, okay, we can try to convince you. So here it is. There are basically three things that can happen to that angle A. It can be acute, which is less than 90 degrees. It can be 90 degrees, or it can be obtuse, which is more than 90 degrees. All right? So those are the cases that can happen. So let's first take, okay, so let's say that it was acute, which means that my angle that has been given is basically less than 90 degrees. All right? So in that case, I'm going to just draw it out. So let's say here's my angle. Okay, so let's say something like this. All right, and then, so here's, I'm going to draw a big long line here. So here's my angle A, all right? And now, so what it says here, so since angle and then side is given, so let's say that this side is given, all right? And I'm going to give it an actual number, okay? So let's say this is 10. And then, you know, this angle A, let's say this is 40 degrees, all right? Just so that it kind of gives you some context. Doesn't have to be, all right? It can be any angle as long as it's less than 90. Now, I'm going to drop right here the kind of height of a triangle that I would have been constructing, and then, you know, you'll see what I mean shortly. And so my construction of the actual triangle, okay, so let's say, so I can create a triangle like this, right? Where that's your A, let's say this is your B, you know, this would have been your C right there, okay? So I can do that. Now, what can happen as I'm constructing this triangle? Now, if one thing can happen is that I don't even have a triangle. So, you know, if this, let's say if I make this shorter, if this length is shorter, right? So like I can't really swing it, okay? And I can't really attach it, okay? If it's shorter than this height, right? So if it's shorter than the actual height, no matter what I do is I'm not gonna get a triangle at all right? So you have to be careful with that. So just make sure that this length is actually longer, okay, than this particular height of that triangle. And you can find the height of the triangle because the height, notice that it's 40 degrees. The height drops down to a perpendicular. So if it's perpendicular, that means that it's 90 degrees, and then you can use your trigonometric ratios, right? Your opposite, adjacent, and hypotenuse. And hypotenuse here is given as 10 for that. So you know what that height is. Okay, so if it is shorter than the height, then I have no triangle. Okay, not a big deal. Now, the other case that can happen is that what if, okay, so this was, let's say, I'm going to take the second case. What if this was longer than this distance, okay, that I had here? Okay, so what if it spans a little bit longer? Notice that if it's longer, okay, then the actual length of 10, so let's say if it's 11 or 12 or something, anything longer here, notice I'm not going to be able to touch until really I just start to really swing out, okay, and I'm going to get to there. And now I have constructed a triangle. In those cases, when this particular side is longer, in this case if it's longer than 10, then you have a very unique triangle that you have constructed. And in that case, no problem, great. That means that we can go ahead and work with this triangle and use the sine law to find everything that we need. Okay, so far it's not very ambiguous, right? Okay, so you can have a triangle or you cannot have a triangle. Where the ambiguity comes in is when this right here is actually, so here, longer than this height, okay, but shorter than the length 10. Okay, so if it's shorter than that, but longer than the height, notice what's going to happen. If I swing it in this direction, oh, I'm going to create a little triangle there, right? Now, I'm going to replicate this just so that you can see it. Okay, I'm going to duplicate that. Let me duplicate it, okay? And I kind of swing it back. And now, okay, so this was, you know, attached right here, but it can also attach on the opposite side, like this. Now, it creates an isosceles triangle there, you know, around that height. But these are the two instances that we can have. So if I'm going to redraw it, is that we can have this happening. You can have a triangle All right, I'm going to try to draw it. So it's going to be either looking like this, okay, or it's going to be triangle, okay, which is, okay, going to be looking like that, okay, where, so let's say, you know, this was 10, this is 10, this is still known, let's say it was 40, this is 40, and this, okay, this is exactly the same length. And notice, so this is your angle, side, that is known. Now, it has to be, again, so it happens when, okay, that actual, so I guess this is side C. Okay, so, sorry, side A. I apologize. So that happens when the A is actually greater than the height, but it is less than, okay, this was our, I guess, our C there. Okay, so this is C right here. But it is less than C. So when it is somewhere in the middle, that's where the ambiguity comes in. All right? So if that happens, then we might have two triangles. And notice that clearly this angle and this angle, they're not the same. But they are complements of each other. And they will have the same sign. And that's where that ambiguity comes in. And something that you're going to have to be aware of. This is really the only case, okay, this ambiguous case that it happens. And you're going to have to know how to work with this particular case. So I'm going to just show you, okay, so what this means is if I was using my sine. So if this is my height right here, I can find that height. So that height, let's say calculate it. Okay, so notice that what I have is, okay, and I'm gonna take this as my triangle. So I'm using just trig, okay, ratios here. So I have, this is gonna be sine. So that height is sine of 40, which is equal to opposite. So that's my height over hypotenuse. Now hypotenuse is 10, right? So that opposite side, so this right here, so this is the height of the triangle. So the height of the triangle equals, okay, if I bring this 10 over on the other side, it's going to be that. Now, whatever that might be, let's say, so 10 times sine of 40. Okay, so it's approximately 6.43. Okay, let's kind of round it off, 6.43. So notice, if your A is basically, you know, greater than 6.43, but it is less than 10. So let's say, so anywhere in between there. Okay, let's pick 8, for instance. So if that A is equal to 8, so that means that I have this right here is equal to 8. And let's say, you know, this right here is equal to 8. That creates two triangles. But for my sine law, okay, the way that I have set it up, notice that from that sine law, so sine of A all over, okay, now A is 8, okay, equals 2. And now this opposite one, so this is going to be, I guess, sine of C, the way that we labeled it, all over, okay, this is 10. Now this A is 40. So the sine law is identical for those two triangles, right? So it's exactly the same, but the triangles are clearly different. And this angle can't be the same for both, but yet you might get trapped here. Now, if you remember kind of the unit circle, and as you were working with the sine law, you know, sort of the sine, so if you swing around the unit circle, you do notice that the sine, okay, as you keep the angle, as the angle gets bigger, so sine of the angle is equal to the same thing as sine of 180 minus the angle, right? So those two are identical, the values, and that's why the sine law here works, but you yourself have to catch that if it happens. And it happens in this instance when you have an angle and a side that is given. All right. So if I would calculate this, and let's see what this would give me. So I can find what sine. So So this is sine C is going to be equal to, so if I kind of rearrange this is degrees. Okay, let's say this is 8. Okay, so what does that give me? Okay, so that's my h, so right there, and then answer divided by 8. Okay, so that's what I have here. 0.80348 and so on. Now I want the angle, so I want the inverse of that. So let's do that. Where's the inverse here? So let's clear that. So sine inverse of 0.80348 and so on. Okay, so that's approximately, let's say 53.5 degrees. All right, if I round it off. Now, this value is acute, right? It's an acute angle. It's less than 90, which means that the sine law always calculates this angle. But if you know that your triangle actually looks like this, right? Then how will you find this angle, which is now obtuse? Well, that is just using, okay, the complement, so 180 minus 53.5. Okay, and now with that, let's see if it actually, yeah, I kept it, so I'm going to keep it minus the, so it's going to be 126.5, I guess, approximately. So that is this angle. They have exactly the same sine value because, again, remember that sine of angle is equal to sine of 180 minus the angle. So in this angle right here, right, so if that's in the first quadrant there, in this case it was 40 degrees, it's going to be the same thing as, okay, the opposite side, okay, as you go through. Sorry, I said 40 degrees. We had 53.5 degrees, okay, this one right here. Okay, so these ones are identical. Sine of 53.5 equals to sine of 180 minus 53.5. Now, of course, you don't have to believe me, you can check it, but from your unit circle, you should also remember that has to be true, right, in terms of those values. Okay, so that is why this case is called the ambiguous case, because we might get, or we might create, two triangles with exactly the same sides and exactly of that same angle. In this case, I took 40 degrees. And we might get two triangles, all right? So this is when your angle A is less than 90. Now, what would happen if the angle A was equal to 90? Now, in this case, okay, so if you had that the angle, okay, so the angle A was actually 90 degrees. In this case, there is no ambiguity at all. Okay, so because if you would be creating this, really, let me just draw this out properly here because it was 90, I said. Okay, so this is my angle A. So really there's only one triangle that you can create here, which is this one, right? When you have a 90-degree angle, that's the only thing you can create. You can't create anything else. No matter what that side will be, it's not going to give you two different types of triangles. Okay, so when it's 90, and when it is 90, you don't even need to use the sine law because you can just use, opposite over hypotenuse, adjacent over hypotenuse, which just goes straight into the trigonometric ratios. So sine law is really not needed here. Okay, so and there's no ambiguity when that angle is 90. So the last one, when the angle is greater than 90, meaning it's obtuse. Now this also will give us a little bit of a headache, but okay, not as much as with the acute. So let's say if it's, so if my angle is like this, so I'm going to span this out here. Okay, so this is my angle A, right? Now this is my length, so let's say we still keep the length as 10. So in here, if you wanted to create a triangle, then this would have to touch this line somewhere, right? Now, the only way that it will touch it is if it's actually going to be longer than that side of 10. If it's shorter, then there's no way you can create, okay, anything, okay? Because if it's shorter, that means you'll never actually create a triangle. So this angle right here has to be longer than 10, or at least has to be longer than that side that you know. But if it is longer, then again, you're only going to create one triangle. Because if you go past this, well, then this is going to be creating a different types of triangle, right? So this is only going to get one triangle. So in summary, the ambiguity comes from the fact that whenever you are given an angle, a side and a side, this is the only time that it happens, or, you know, some teachers might like to write this as S.S.A. Doesn't matter because you can read them back and forth. I like to, again, remember just this one, okay? That's a little bit more memorable. So when this is given to you, always just be careful, okay? So if your angle is obtuse, okay, so if it's more than 90 degrees, and you actually do have a triangle created, then it just gives you a one unique answer, and you can go ahead and use your sine law, no problem. If that angle is 90 degrees, then you don't even need the sine law. You can just go ahead and utilize the regular trigonometric ratios. If the angle is acute, then you have to be careful, okay? And again, that brings you back, okay? If it's acute and those two sides are given, then be careful. Are you dealing with this type of triangle, or are you dealing with this type of triangle? All right? Now, sine of the angle that you are given is always going to give you the acute answer. All right? So whatever that is. So that means if you're dealing with the triangle, which looks like this, okay, if that is given to you, remember, because so it can be either this triangle, you know, or this triangle, right? So it can be either this, that's one triangle, or it can be that. And the sine, okay, is always going to give you this angle. So if you're going to want this angle, because if that's the triangle you're dealing with, then you're going to have to take 180 minus. And then from there, you can go ahead. Once you have that angle, then you can compute, you know, the other angles, and then you can find the side throughout this. Okay? That's the ambiguous case. This is really the only time that it happens. Everything else is good. Now, of course, there are some instances where the information might be given and you can't even use, okay, the sine law. You might have to use the cosine law, or maybe nothing will work. But, okay, please remember, okay, if that is given, you know, an angle and then two consecutive sides right after, okay, then that's what you have. All right? Okay, thanks for watching. We'll see you in a future video. Bye, everybody.